Oh, it's the wrong. Oh. Eat that. Yeah, but you got like a good mic then, right? Because those big ones are usually better. Okay. Okay. So Fabro fell away. Fabro! Yeah, they fell away. So I don't know. Should we like do the presentation? I don't think anyone's watching. Oh, they're back. Hello. Oh, so yeah, obviously I'm streaming right now, right? So you know that. I don't think they can hear you though. Maybe I'll. Do you want to be heard? I can make you heard if you want. Yeah, because I just need to put it on a different. Now, if you talk, you should be heard on the stream as well.
Hello?
I think that worked.
Yeah, I can hear myself. But that's not good.
Yeah, I'll put you a bit softer. There we go. Good. Okay, your question about audio jack.
No. My question was that in order to fit my, I can't fit my sound card in my new build because there's there's different sizes of the Express port, right?
Yeah.
Yeah. So the sound card, the size of the sound card is like this. The smallest one is like centimeters maybe, and then there's the middle one, and then there's the big one. Where you use the size where you usually put the graphics card. I'm not a hardware guy, by the way. So my question is, if I can put like the smallest size PCI Express connector into a medium size connection.
I think that will work. Yeah. Like my rule of thumb with PC things is that if it fits, it'll work. Oh, you fell away again. They fell away. Okay, this is gonna be difficult. Oh, you fell away again. You're back.
Okay. Yeah. Well, maybe I try that then. So I can actually have a mic. That would be great.
You haven't even tried. I would just try it out. What could possibly go wrong? Okay.
Yeah.
Oh, it's sluggish. Because I'm streaming as well.
Yeah. Well, it's present. What is it called? Reveal JS or something.
Yeah, I'm building this. I have a Nix thing. Like I made this before, so now I abstracted over that one, so I can make another presentation out of it. It's using Pandoc. So I have this org file that's being thrown into Pandoc through Nix, and then yeah, that's it. Oh, and I was also having some problems with the code. So now I have a light team that actually works. But before I was trying to use that plugin with like set. I'll just like modify the result in Nix. But no, it's fine like this. Yeah. We'll just use a light team. Fine, it's fine. It's not code.
Yeah, well, I did my presentation in Reveal as well. But there's this thing that I've seen people use. It looks like you're presenting from a text editor, but it's not Emacs or anything, something else. But basically, like, I don't know,
ASCII. I've seen people present from Emacs as well, but I'm not skilled. Yeah, I'm not skilled enough for that. Oh, you fell away again. Come back, Skybro. You fell away. I need my audience to have active commentary. Welcome back.
What's going on?
You keep falling away.
Maybe. I don't know why. Strange. Hold on. Wait a minute.
Okay. The presentation can wait, What do you even say here? I forgot.
No, it's. Oh, you want me to be like an audience now?
Yeah. Well, interact. Yeah, axe with an axe. Just interaction is fine.
Yeah.
Just show it or whatever. It's gonna start out really easy for you because I had to do this for the entire company, so even the business people need to understand. So in the beginning, it will be like easy peasy, and then we're gonna ramp up difficulty quickly, like I do.
Oh no. Will there be lenses?
There won't be. Yeah, a little bit on the end. That's the bonus slides. I just added them on the end.
Bonus slides are lenses.
Yeah. I don't know if this version has them, but we'll see. Okay.
In a moment, maybe my earbuds will be charged as well, so I don't have to hold the damn phone.
Short or
charged?
Charged. Okay.
Yeah.
Okay. MTL. How are we getting here? Monad transformer library. And I made a promise to the business that you won't need to know what a monad is. So you won't need to know what a monad is. For real. Okay. You can ask questions at any time. Please interrupt. I practiced, so I know how to pick up the thread, so to speak. So if you have any questions, please ask them. Okay, so the motivation for this talk is that I want to satisfy some curiosity I saw on a team. Like, I saw some PRs of people like, trying to work with this stuff, and I want to take this opportunity of this curiosity to also explain some costs and benefits. So that's like my primary motivation. But I also believe this is a bit of a challenge because, you know, I need to explain this to business as well, and I think it will be fun to do. So let's talk about the goals of this presentation. I want to answer a couple of questions. So the first one is context-based. Why do we use types? And this is to help certain members of the audience participate. And then on the next level, we're actually going to dive into like the heart of the presentation, when to use a transformer. And after that, we're going to talk about some of the library aspects of MTL. That's like the most difficult part. And it's important to keep in mind that MTL is more advanced form of Haskell. So yeah, it gets quite difficult at the end, but it's fine to zone out at that point. So we want to have fun, and to do that, I introduced this bonus game, Spot the Monad. Every time you see a monad, please call out, because that's how you learn to recognize them, just by seeing a bunch of them. Kind of like colors, you know, red, green, blue. Once you learn to recognize those, you know what colors are. So that's the idea behind that. Okay, so we start out with the first question. What can Johnny do if he is of type IO? And I
see a monad.
You see a monad? Oh wow, that's soon. Congratulations. IO is of course a monad. But Skybro, now you're here. What can Johnny do if he is of IO? Can he serve a web page? Can he answer yes or no? Can he read a file? Or is Johnny God and can do everything?
I believe Johnny is God.
And you are correct. Johnny is a god and can do everything. So it's important to note that like most programming languages will live in I/O. So for example, Python, Java, etc., it will all live in I/O. That's like the default assumption here. And Haskell is different in that aspect, in that we have choice. And to show you what I mean, we're gonna have the second example, Betty. So what can Betty do if she is of yes or no? And that data indicates that we are creating a new type, and the other side of the equal sign, yes or no, means we can have values of that kind of type. So let's answer this question. Can she serve a web page? Can she answer yes or no? Can she read a file? Or is Betty God and can do everything? Do you know, Skybro?
Oh, me.
Yeah, so who else?
she can answer yes or no.
Exactly, you got it. So this is like the other extreme, right? On the one hand, we have like I/O, where you can basically do anything you want. And this is the other side, where you can only answer yes or no, and you can't read files, you can't start a web page, etc. So we are actually exploring the space in between these kind of things right now. Like, we want to maybe have some side effects, but we want to maybe model them, etc. So that's kind of what this talk is about. But to drive home the point of type, we let's say that our web server crashed, Richbook is down. Which function will we explore to see where a bug is? Will we explore Johnny, which is of type IO, or will we explore Betty, which is of type yes or no? Skybro?
Well, in this case, I believe we will explore Johnny.
Exactly. So what does it mean? Why do we have types? Well, we have them as a thinking aid, and so we can eliminate part of our code base if we are looking for bugs, for example, because we don't even have to look at Betty anymore if our web server crashes, because it doesn't even make sense, right? And secondly, we are able now to spot bugs early on in the process, because if types don't quite align, we'll get an error from the compiler. We haven't seen this in this example, but they'll show up later. And crossout is run computations. We're not going to talk about that right now. Not yet, at least. So that was actually the first part of this presentation. Why do we use types? We answered that. Now we're moving on to the next part. When do we use transformers? However, I need to take a step back and inform you all that it's gonna get more difficult from this point on. So if you feel you're not getting any more value of this presentation, it's okay to leave, or zone out or whatever. It's don't feel embarrassed by that or whatever. It's like this presentation is to be fun. So I can't keep it as simple as I would like to. See you later, man. So let's move on to type variables. In here, we're wrapping Betty inside a maybe value. So instead of answering what C can be, we now are going to count. How many possible values can Betty be? 1, 2, 3, or infinity? Skybro, do you know? Skybro? Skybro! You're muted. Oh, does anyone know? Is anyone watching?
Hello?
Oh, hey, are you there?
Yeah.
Do you know the answer? Oh, he was muted.
C?
Exactly, it's 3.
C, but that's 3. So
yeah, that's why I said exactly. And its book is also replying with just no and nothing. That's correct answer. So we can count, right? So we can just count in this case the possible answers. Okay, let's move on. Oh. Why would we use a maybe ever? Well, it allows us to do this kind of stuff, right? We're organizing a party and we want to know if Carl's going to go to the party, for example. So we'll ask Johnny nicely, hey, Johnny, do you go to the party? And then we'll ask Betty nicely, hey, Betty, do you go to the party? And now we can reason with only the yes or no values. Like we are taking the maybe answer away and we are only reasoning in terms of yes or no. So if Johnny, in this case, is nothing, this entire code block will stop executing and call will become nothing. And the same goes for Betty. If C is nothing, this entire code block will stop and call will become nothing. However, if that's not the case, we get the values yes or no, and we can reason about that. So it's kind of like happy path reasoning. And this is why people like, monads. Oh, Skybro, did you see the monad? Or anyone?
Yeah, yes.
Which is it?
The maybe monad.
Yeah, the maybe monad. Congratulations. Don't forget about that, huh?
Do I win?
You win the big prize. Okay, let's move on. We had some pretty nice code here, but we can make it better. We need to improve on errors. So let's first introduce this result data type, which is either an error A or an OK B. And if we wrap around Betty in a result, yeah.
If the result data type is either an error or a B in this case, why isn't it called either?
Well, that's just a name, right? What do you mind? we're just talking about errors right now. So anyway, big brain indeed. I bet I'm gonna get that question. Anyway. So let's count again. If result is of type unit, yes or no, how many possible answers can Betty be? 1, 2, 3, or infinity? Does its book or Skybro want to answer? You're mute. Okay, so, its book answered with C, and you're all right. Because we made it unit, it can only be one error, and we multiply yes or no by, okay. No, it's not infinity, it's C. Why would you say infinity? Unit, yeah, it's unit. What else would it be? I was holding my damn phone. Oh, okay. So Skybro is out for the talking. That's unfortunate. Could make B anything. Yeah, you can make B, but we're asking about Betty in this case. So we are plugging that type result with a unit here, and you just yes or no there. So it's still three possible answers. Okay. Right, so now we can talk about isomorphisms, because we can change our maybe value into a result, and we can change it back from result into a maybe. Isn't that great? It's like a self change. Wow, aren't we happy just by seeing this? This makes me feel happy that we can express types like this into each other. Okay, cool. Let's move on to improving errors. What if we, instead of say that Betty is of type result unit yes or no, we're gonna say C is of type result errors yes or no. How many possible answers can C be? Is it A2, B3, C4, or D infinity? Does its book or Skybro want to answer this? Or anyone else in chat, for that matter? We have a delay. Okay, I guess silence means you don't know. Yes, you're right. It's C, 4, because OK can be 2 with yes or no. And the errors are also 2 with Johnny nothing and Betty nothing. So we count those possible options together and we got 4. You're right. Congratulations, it's book. So now we can improve our call code by tagging the maybe values with errors, making this entire thing a result. So if Johnny in this case is nothing, we are gonna tell our code that we are resulting an error for Johnny. So this block gets stopped with executing, and we tag it with which function went wrong, what went wrong with it. Same goes for Betty. If she doesn't know, we tag it, right? Adding Haskell to my LinkedIn now. Yes, you learned Haskell. Isn't that great? Okay. Right, so now we no longer squash the tags and we know where errors go wrong, which is great. Our code is now almost production ready. In fact, we have similar kind of code in Riskbook. So this is a technique we're currently using. However, you may ask, what about logging? You know, what about the case where Johnny goes, but he is actually saying he doesn't want to go? You know, we know the result of Johnny going, but he's saying he doesn't want to go. Whereas we know that Johnny is actually a bit of a party goer. So if he says he doesn't want to go, there may be something wrong. In this case, we can still continue our program because we know how to continue, but we at least should like emit an error or a warning. Not an error, but a warning. So that's why I want to do logging, right? Right. And this is where we enter the transformers. To do this, we add the logging T transformer to our result monad. So after doing this, we are able to actually choose which monad we are working in. So in this case, we are lifting Johnny over the logging T and we can work inside result. And in this case, we work directly in logging T. So we can choose in which monads we're working by just lifting, right? That's what transformers do. So we make the monad bigger, make it 2 monads actually, and we just choose in which one we want to work. So notice lift, it's important. Okay, this is the full code that we want to have with monad transformer. So now we can log. However, as you notice, our code is blotted with lifts, which is kind of ugly, you know? I don't like this. It's redundant. We're repeating ourselves with these lifts. It's awful. Do you even lift monads? Yes, we lift monads. It's what you do with transformers. But can we get rid of it? However, right. I also want to show how you can use this thing because it becomes a bit more difficult because now you have to first unpeel the logging and then you can inspect the result, right? It's not as straightforward anymore. It's just a pattern match. You first have to do something with the logging. In this case, we're logging it to SD out, and then you can reuse the result. So it all becomes a little bit complicated. Why do you want to do this? That's actually a good question. Does anyone know why you want to do a transformer stack like that? Does anyone know? It's actually a bit more difficult question. I would ask this to like more senior. Maybe Skybro knows. Why would you want to use a monad transformer stack? Do you know? Are you there, Skybro? Well, it's a pretty hard question, I guess. Put people on the spot like this. It's also surprising me. It takes a while for people to gather their thoughts being asked these kind of questions. That's okay. I guess that's normal because it gives you an API working with a stack plumbing. I wouldn't put it like that, but it does give you an API, yeah. So you don't have to do all that shit manually. But why would you use a transformer stack over, for example, working directly in I/O? Let me put it like that. What benefit do you get from a transformer stack versus just working straight in I/O? Effects are more explicit. That's true. I/O is God mode. Okay. I'll just answer. I won't answer. Would I answer? I'm not even answering this. Okay, so we can decide at call side what we're gonna do with our logging. Here we're just saying we want to log something, right? However, in this case, we are saying we want to log to SD out. But what if you want to log, for example, to the database? Or what if you want to log to, like, I don't know, where do people log to? std error, for example, you could log to there, log to a file. All these kind of things, they get postponed. So we still get to log, but we don't decide where to log yet. That's done later on. Same for the error, right? We know that there is an error in this code and that we have to stop this execution of this block if we are getting a nothing here. However, the calling code, the call site, can still decide what to do with the error. So it's not like the entire program has to halt. That's not really... Dude, what do you think this presentation is about? Monad error. It's MTL. Oh my god. Let's go to the next level, okay? There'll be dragons here. So yeah, again, like you get the opportunity to leave, but things will become more difficult from here on. So yeah, problems with transformer. Calling lift is not dry. We are repeating ourselves by selecting the transformer we want to working, and that's annoying. I don't really care which level the transformer stack is. I don't care the ordering of the thing. It doesn't interest me. Okay, just give me logging. Just give me errors. You know, don't be so explicit about those things. And any stack above 3 becomes bloated with lifts. So we've only seen logging. We've only seen what the other thing? Errors, right? But like if you're gonna add, for example, database access to this thing, if you're gonna add like Redis access, if you're gonna add maybe you want to have continuations or resources, like suddenly you have to like have 6 different lifts just to select the right one. That's not doable. So and there's the thing called lift width, and I don't want to talk about lift width, but there's lift width, and if you want to Google something crazy, look for lift width. Okay. So let's ask again, why types? They are a thinking aid, they help us spot bugs early, but more importantly, they help us to run computations. That's what we're going to talk about right now. So yeah, this is actually the dragons part, right? So let's say we have a constraint on our Betty. We have a num constraint on Betty. How many possible answers can Betty be? Does anyone know? Does anyone want to answer? Is it A1, B2, 3 infinity, or C infinity, D infinity? Does anyone want to answer this? Is anyone still watching? It always takes a while for chat to answer. Infinity. You're right, it's book. Man, you're on a roll. Or whatever num can be. Num can be any number. So you're right. It can be floating point, double, etc. And you can actually construct these things in Haskell, because you can just, you know, put a 1 in there or whatever. You're on a roll. What is this num thing anyway? It's a type class, so it allows us to do these operations, plus, minus, etc. Right? Anything you expect from a number, and we can get a num constraint by making an instance. That's it. So this allows us to put a floating point in Betty. This allows us to put integer in Betty, etc. Right, and they should also have implementations, but I left them out because it's not that interesting. And we can also invent our own numbers. So if we want to, for example, make our yes or no type a number, we can do it like this, right? We just make an instance for that, and now it's a number. Hooray! We can put it in Betty. But my question is, what's wrong with this kind of code? Why is this specific implementation wrong? Have you never seen an instance? Yeah, yes or no now is a number. Now we can yes plus no, for example. We can put it in Betty. Yeah, we can put it in Betty. 消化. Okay. Okay, I should rephrase this probably during the very professional talk. What is wrong with this, Skybro? What would your intuition say about this kind of implementation for plus or minus? Where we just throw away one argument. Don't say that during your talk. But I want to put a number in Betty. It's a shitty instance. Ship it. Okay, it's a loss. Okay, we don't have commutativity. Look at this. X plus y is equal to y plus x. We are dropping y. So if we flip it around, it will be x is equal to y. We break the laws. There are laws for type classes, okay? It's important, but that's for another talk. Anyway, how about this? We're gonna make Betty a monad. Have you ever thought about that? We could just wrap Betty in a monad and then see is a monad yes or no, right? How many possible answers are of this kind of Betty? 1, 2, 3, infinity, or unknown? Actually, come to think of it, that other one should also be unknown. Does anyone want to answer this? So we don't know which monad this is. Also, play the game Spot the Monad. Unknown, yeah, it is unknown, isn't it? Because this monad can be an infinite sum type. So, or it can be, you know, just either. So it can be either, it can be all of these. It's unknown. So let's move a step further. Let's do something like this, where we still have Betty. She's pure yes. And now we're gonna do case of Betty. Just X or nothing, no. This is valid Haskell. This compiles, by the way. Because we're just saying, Betty, now, you're a maybe. And Haskell's like, okay, it's perfectly valid. We have an instance for a pure, which is just right? So what's the value if we do this of D? Does anyone know? Skybro, It's Book. Do any of you know the answer? What's the value of D? Anyone? It's kind of surprising how long it takes for. Okay. Yeah. So if no one's gonna answer, I'm gonna say the answer then. It's obviously yes, because Betty is just yes, and then we pretty much on it. Okay, let's move on to the next one. What if we do this case of Betty, and we do right or left? What's the value of Y? It's also gonna be yes, right? Again, what are we gonna apply no to Betty? What is the value of X? What does this even do? Does anyone know what this even does? This is also valid Haskell, by the way. It's so funny to talk about this stuff. Is anyone here? Did my Chatterino correct? It's always yes, right? Yes! But aren't you seeing this? We are applying no to Betty, and it's just a monad. Do you even know what's going on here? How does this work? It is yes, you're right. Yeah, you're right. So we got this function called const. Let's go, I don't know, let's go here. A to B to A. And if we look at the monad reader instance, for arrow, it will use const for pure. It's for monad. I don't know if I can look this one up, unfortunately. It's kind of it's using function arrow. So and a pure will be const. We're in a meeting. Okay, see you later, man. Let's yeah. So this is all valid Haskell. So let's move on to the next part of the presentation. How do we use this kind of magic? Let's say we just want to have a monad that can do errors, and we want to have a monad that's a logger. Now we can finally put this to work, and we won't have any more lift. However, the syntax changed a little bit here with the throw error thing. But yeah, so we don't have to do any more lifting. However, the call site changes a little bit as well. So we now have to still do run logging T, and we also have to run accept T, because if we don't do this, it becomes a little bit difficult to unwrap that either. So yeah, it took me a while to figure out, by the way. Yeah, so the advantages of doing it like this is that we no need to call lift. Stack order is also determined by the call site instead. So we don't have to care about it in our client code anymore. Also, this is potentially better testable. This is shared with the transformers, by the way, because we can choose what to do with the logging and the errors. So we can, for example, expect something to error or something not to error cleanly. Or maybe we can even expect something to log, right? We can see what the logging was. Yeah, so the big disadvantages of using MTL is that type errors become awful. And we also have that small n squared instances problem. But I'm not going to talk about this right now. In fact, this is the presentation, I guess. It's actually quite short, come to think of it. Even with my like little interruptions, it's only 30 minutes. And it took me so long to make this. Dear God. Thanks for watching anyway. Leave a like and subscribe. Oh, we don't have bonus slide in this case. I need to get the bonus slides as well. I'll be right back. Maybe I didn't push, or maybe I didn't pull. I probably didn't pull. Wait. I'm gonna get bonus slides. Skybro, are you there, by the way? Yeah, I didn't build correctly. Okay. Bonus slides. Okay. Bonus slides. In between slides. Oh, it's so boring. Bonus slides. Oh, I'm so happy with bonus slides. We need to apply correctly. So we make this function, which is a monad reader, m of a, and we can just do +1, and then we'll do 2, which will be 3 actually. But we can also make it float, you know, because the call side is also polymorphic. Okay, apply correctly 2. We can make a monad reader of a number, and then we can wrap it inside an n, and then we make another monad reader, wrap it inside an m, and then we can result in a, right? And then we can do 2 + 2, which is equal to plus, obviously. This is also valid Haskell, by the way. Oh, right, and we also get row type polymorphism. This is where the lens comes in. So, you know, and we can have state as well. I think I did it on an interview once. Don't do this in an interview, by the way. But, yeah, so we just say like, okay, do you have yes or no? And then you can just view that from something that's app settings, for example, or something that is yes or no directly, which will be identity. It's all a bit confusing. This presentation is for the company I work for. But I was like, okay, I can do this on stream as well, right? We have a bug in our presentation, by the way. I'm gonna fix it right now. Oh god, where is my website? They are new to MTL. Kind of. I mean, yeah, sort of, yeah. This is why I say you can easily apply to a Haskell job. You know a lot, Skybro. You don't realize how much you know. Right, fix bonus slides. Why am I even committing this? Like, I don't really care. I'm gonna run it here anyway. Like, I'm sure they could figure it out, you know, but I don't think they actually know what's really going on. Like, that application stuff, I bet that's new to most of them. Well, which I just did with that monad reader, right? Fun for practice. Look at these slides. Welcome, Caroptical. They are written in org mode. I feel you should focus less on the fun for practice questions. What do you mean by that? Would they be convinced to use MTL? I don't know. I'm not really trying to convince anyone to use MTL, to be honest. I just thought I had to explain it. In fact, oh, we kind of skipped the alternatives as well. Oh, because I didn't have it yet. Welcome, Caroptical, by the way. I don't know if I said that already, but yeah, so there's also the alternatives. I added them later. So we got like free monads, we got freer monads, we got polysemi, we got fused effects, we got F, and I have no idea which is best. Yeah, Caroptical, will you stream Advent of Code? Because I never do. How is your quick mouse? That's a good question. I'm interrupting other people's conversations again. Oh, wow. Oh, sorry, but you said on the fun for practice questions. What do you mean fun for practice? That's like my entire presentation questions. No, GHC is not the one that, well, maybe polysemi as well, but I know there's a patch for F. Oh, these you mean? I mean, I shouldn't focus on these, I guess. Well, this is to introduce the idea that you can make a maybe out of Betty if it's a monad M. So this is like the step up towards full MTL, right? Because you got a polymorphic monad. And then you're gonna, you know, step up to suddenly having 2. I thought this step already was too big. I don't know. But this is like the entire solution right here, right? Polysemi, by the way. Polysemi is the best. Would you say polysemi is the best? I could add like a quote of Corruptical, endorsed by Corruptical. Oh, you spelled it wrong. I probably spelled lots of things wrong. I don't care. Polysemi. Wait, are you sure? How would you misspell that? The coexistence of many possible meanings for a word or phrase. That's a good name for the library. I find polysemi easy to use. Did you use anything else? Did you go to the struggles of this? Actually, figuring out I need to use run except t for this stuff took me like 30 minutes or something. Okay, I find it hard to. I mean, I respect your opinion of like, yeah, sure, it's easy to use, but if you have not used any of the other ones, then it's like hard to assume that as expert opinion, right? Your presentation was quick for sure. Yeah, but you know, all my presentations are quick. How do you manage? I don't know. I feel like I put a lot of information in here. Even bonus slides, you know. We even have rotate polymorphism. But like, if you don't know anything about Haskell yet, this presentation is gonna be like a bombshell, I think. It's from an expert. No, but like, you know stuff about Haskell, so I would say you're an expert. Compared to like normal people, you're definitely expert. That's how you should look at it. And by normal people, I mean like random people on the street. What was I thinking about? Oh, that comparison. I'm getting dizzy of all this tittering. Okay, polysemi is recommended, which is still misspelled, by the way. We need to rebuild our presentation. I bet there are a bunch of more spell errors in here, but I don't really care. I don't care enough about the presentation to fix them. Normal people, yeah. Well, that's like how everyone else looks at it, right? Why shouldn't you? My presentation explained Haskell syntax, algebraic data type, pure functions, functor applicative monad, plus live code. Oh my god, I'm not even explaining monad in here. I don't even know what to explain about monad. I'm just like, oh, it's this type class. That's it. we can pattern match. I feel your criticism is fair. We shouldn't stick on this one too long. Maybe I should strip this one out and put it in the bonus slides. But I feel this is important. This juxtaposition between we can make Betty just nothing, and we can make Betty right or left. So we can. I guess you used like error and okay. I know fused effects will accidentally perform much better than polysemi for simple examples. Accidentally. I don't for the alternatives, I'm not even really looking for performance. We just want to manage it, to be honest. Because what we're doing right now is reader TIO, I guess. So that's not really any effect management at all. That's just IO with a fancy name, basically. Actually, that's transformers, but dumbly. That's like not transformers how I did in this presentation. Okay, I'll follow Skybro's advice and I'll move Betty to the bonus slides because it's not that important to apply. Although I find it very funny to talk about that, you know, that you have the arrow, but it's not important at all for this presentation to talk about that. So maybe I shouldn't. But it makes me laugh, you know? I don't know where my website is, okay. Yes, my presentation is in org mode. Bonus slides. Oh my god. So we'll delete this one. What is the value? Yeah. I thought all the things explained was important, but in the end, I think people didn't get half of it. So the questions, do they kinda know MTL? And do you want to give them a deeper understanding? Or do you want to introduce them to what problem it solves? I want to introduce them to what problem it solves, I think. I'm not gonna explain, I'm not gonna give them a deeper understanding of it. They have to figure it out themselves. I don't think I'm the right person to give them a deeper understanding. Like, if they want to get a deeper understanding, they first have to think about it themselves, and then they have to come with questions rather than me force feeding a bunch of information. Because I don't think that it works like that. Well, I'm not like any teacher or whatever, you know. Maybe we should ask Corrupticle how to do this correctly, because he actually is a teacher. Or he's like, you know, I think, yeah, he's like a postdoc, right? Like he actually taught on school or whatever. Because that's part of PhD, right? You have to teach. Sometimes teacher. There you go. He's actually a teacher. Oh, what would you say? Should I go deeper into MTL stuff? Or should I keep it like this, nice and superficial? Oh, you actually still give class? Wow. And who your audience is. I suspect this will be useful. Okay, let me put it like this. I have not seen anyone else write code like this in Riskbook. So even like not this one. Even this style. I would love to see more of this style. You know? Where we just tag things with errors. It's so nice. Why don't it's also like really easy to do, no advanced shit at all, no MTL magic, no effect systems or whatever. And you will know where errors go wrong. It's beautiful. I would be quite happy if more people would write like this. I teach scientists who have never coded before to use Python as a tool. The slides are removed. No, I didn't remove them, I moved them to the back. Because they're bonus slides. I'm not even just like, okay, we got more time, let's look at more code, guys. How are you gonna introduce bonus slides, you know? I've never done that. Didn't to work, no more lift. I still have some of those. I think this is useful because it shows that the M can change into a maybe, and it can change. Maybe the questions are not that useful. Oh, this is incorrect. This is also a none. You're getting, what tablet are you getting? I'm interested in a tablet. Yes, definitely. Well, maybe not this year, but next year. Fancy boy tablet. I need one for reading, I guess. Remarkable too. Oh, it's actually for reading. Or no, I'm confused. Paper tablet. D&D. How could you use it? Oh, you can write on it. That's so cool. Man, I would love to play D&D. Unfortunately, I don't get any nerd friends in Netherlands, so yeah. A friend had one that recommended it over the alternatives. Feel like a notebook. Like, for me, the tablet would be primary purpose reading, I guess. Because I'm doing it currently on my phone and it works, but it's a bit, you know, awkward. So if I get like one that can do reading well, it'd be a lot nicer to have. I would probably read more, you know. You just get like, the experience becomes better. Kindle. I can't use a Kindle because I need to acquire through illicit means books. Yes, I need to. Okay. Fix various things. Alright, let's get another one out. I always get the idea that my presentations are too short. You know, the other thing, like I spent 20 minutes on this now, but I'll probably be a little bit nervous, so I'll talk faster, even faster then. And yeah, I just gotta take my time, you know, find the words. Oh, Skybro makes like an entire party out of it. I don't know why people like it. I feel it's like company have a yearly meetup during the advent of code. Contrived? What do you mean contrived? Well, yes, that's the point of that's the point of those exercises, right? I guess I can run through this presentation again. Be a lot less interesting for Skybro though. I mean, I suspect that the advent of code has another, like, it's similar to like New Year's resolutions where people just are all, you know, holding each other accountable to doing them. And then they collectively all think about failing them as well. That's like another part of it, because I think most people also feel advent of code, you know. And then you're like, oh, we all feel together. Ah, aren't we like a team? Yes. You just like how you get like identity. I use two flags, TDD or ADD, then it might be useful. What is ADD? What is TDD? Do you mean test-driven development? Attention deficit disorder. Algebra-driven development. Okay. I like attention deficit disorder better. Discuss solutions with my coworkers. Oh, there you go. That's like your little that's like your little well, maybe it's not accountability. It's also like social coding, getting to a better solution together. I actually really enjoyed the pair programming session the other day. Maybe we should do that on stream. So trick Skybro in my startup. Okay, I'm gonna actually get something to drink and then we're gonna do this again. I don't have thirsty. And lenses. I could see how coworkers would help as well. Yeah, Caroptical, you're gonna have a great time talking about code with your coworkers. Is the position remote, Caroptical, or is it on site? It's like, that's the big advantage of going on site. You get to talk with them more than remote. Ah, okay. Well, you know, just arrange some pair programming sessions and you'll learn a lot. Although, you know a lot as well. So, yeah. Use transformers to solve a few last year. How would you use transformers? I would do everything in I/O. Have you not seen? Actually, we're gonna modify our cut the crap as well, probably, to use proper logging. Because I need to send those messages later on to my servers. Cut crap. Have you not seen this code? It's beautiful. Although we're starting to use more shell, but it's all I/O. Oh, it's even polymorphic. How about that? Actually, like, a good question is as well, what's the point of monad I/O? You know? Oh, you actually did it. Huh? What the hell? Where's the MTL? I thought you used transformers. Maybe I don't understand. Oh, it's imported. Opcode program. Okay. Oh, you're nesting it here. C, A, sub T, base monad, return type. Why use state? Oh, you needed state probably for the solution. I have no idea what you're doing. But you found throw error. What? Why don't you tag your errors? Didn't we explain this just now? You should tag your errors. Okay, next time we're gonna tell you which slide number. It's not even in section 1. You know, it's even the easy peasy bit. You didn't even do the easy peasy bit. Just a simple tag. I usually tag my... Oh, this is where the excuse is gone. The massive but. There's a problem with typed error, by the way. Yeah, you should use... which one did we use? Blah, 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 blah. Monad. It's a bit confusing which one to use because it's deprecated. I need to go here and then okay, which is it? Which one should I use? Is it either? Well, yes, also either. But there's no. Well, there's error T. What the hell is error T? But it says this constraint for no reason. So annoying. Okay, let's do this again. I was just laughing about the we're using the Nix to build this thing. I'm still confused that I actually did that. I actually went that far and figured out how to build presentations with Nix. There's something wrong with me. I don't know what, but there's something wrong with me. Well, probably has to do with Nix, but rerun stream. No, but like I want to practice. I wrote my presentation with Nix too. Chaotical, there's also something wrong with you. Congratulations. Well, at least they're reproducible, right? God. In the GitHub action. Do you check your code as well in the presentation? I have not gone that far yet. But I'm getting there. I'm getting there. Okay. MTL. Monad Transformer Library. And I promise you won't need to know what a monad is. Downside of typed errors is that you have to map between errors of different domain. It's worth it, but... Now what you do is you just make like one massive error type and use it to your entire app. So you're not gonna do any mapping because you don't care about the mapping. So you're just gonna do like data app errors and you're gonna use it everywhere. If it doesn't build, it doesn't type check, I guess. You actually know how to type check that then. Because I'm using Pandoc to create that thing. Or you're probably using Litverse Haskell maybe for the presentations. I don't know. Could you do that? Your function have to handle every error in your app. Latex/beam. Okay. Even where it doesn't make sense or doesn't appear. No, like, okay, what you would do is you would have... Okay, it's a fair criticism, but we'll get to that. You just have to watch this presentation again, Skybro, because the answer is in here. It's all in here. It's the perfect presentation about MTL. Latex/beam. So I'm actually using org mode for this presentation. This is like Emacs org mode. You're probably familiar with that, but or you probably at least have heard of it. It's just better markdown basically, or yeah. And then we're just using Pandoc to create that thing. So yeah, create from Pandoc thing my HTML file in Nix. I don't know how I did this, but can't wait, never seen it. Yeah, so feel free to ask questions anytime or interrupt me in chat or whatever. I love to be interrupted. I love to be distracted. Okay, my motivation is I strongly suspect that there is some curiosity in our team about this kind of stuff, and I hope to satisfy this curiosity. I also hope to kind of explain the costs/benefits of using this kind of approach, like early on, you know. And I also think that this will be challenging because I have to make this understandable to business. I did the best I could. I don't think I succeeded, but you know, just for yourself. Of course. We are a team. You are a team. Of course you are a team. Everyone is a team. Team A. Okay. Goals. So what are the goals? First, we're going to provide some context by answering the question, why do we use types? And this is to help some members of our audience get up to speed, basically. Then we're going to descend into level 2. When do we use transformers? And this is going to be a bit more complicated than the first question. And then level 2 is it's gonna get a little out there, basically. There will be dragons at that part of the presentation. However, our primary goal, of course, is to have fun. And to do that, we have the bonus game Spot the monad. Whenever you see a monad, please interrupt and shout out that you see a monad. Okay. What can Johnny do if he uses I/O? Johnny I/O. He can serve a web page. He can answer yes or no. He can read a file, or Johnny is a god and can do everything. Oh, there's a monad! Oh, wow! And what is the monad then? Where do you see the monad? It's I/O. Okay, there's only one. But what can Johnny do, audience? Please answer the question. Do you know Corrupticle? It is D. Thank you. Maybe just James. How are you doing? Welcome to the stream. Anything. Exactly D. Johnny is a god and can do everything. Okay, so because every other language is in I/O, this is like one of the special features of Haskell. We can talk about things that are not in I/O. So for example, Python runs most of their code in I/O, meaning that they can read files, they can start web service in whatever function they want. And this is where Haskell is unique. And now we're gonna go to the other extreme. Betty. What can Betty do if she is of type yes or no? She can serve a web page, she can answer yes or no, she can read a file, or Betty is a god and can do everything. Does anyone know? Be isomorphic to bool. Exactly, Corrupticle and maybe just James are right. C is just isomorphic to bool. So this is one of the things we can do in Haskell. We can restrict our type so extremely that the answer can only be yes or no. And this kind of restriction, and what we're going to do today is actually explore the design space between these two extremes, where on the one side we can do everything we want, and on the other side we just have like things like yes and no. So that's what this presentation is about. Okay, but to drive home the point of types, we're first going to answer the question, our web server crashed. Where is the bug? Is it in Johnny, that can launch a web server, by the way? Or is it in Betty, that can merely say yes or no? Which function would you explore? A or B? Does Chad know? Does Corrupticle know? Does maybe just James know? Does Skybro know? Exactly, you would go for A, because it's the only function that can do I/O, right? And since our web server crashed, it can't be Betty at all. So why do we have types then? Types are a thinking aid. They help us understand what a function can do. They place restrictions on a function, so they reduce the probability of certain bugs occurring there. And they also help us spot bugs because we need to remain consistent. And finally, there is also a part of types which we're not going to talk about right now, but we're going to talk about later, in that we can run computations with types. Right, so that was the first level. Just why do we use types, right? I think we explained that very thoroughly. Now we're going to move on to the next level. When do we use transformers? However, I need to remind everyone that the law of 2 feet is in place, in that it's gonna get harder here, and if you don't feel like you can keep up, it's okay to leave or whatever. This presentation is supposed to be fun, so that door is open, you know. Okay, moving on. Type variables. We're gonna need some. Are those your feet? No. In fact, apparently I could insert URLs into my presentation. I'm not gonna show it now. Okay. Type variables. So we can introduce a maybe a thing, and that a can be anything we want. So to set an example, we have Betty here, which is of maybe yes or no. So now we're just going to simply count the possibilities that Betty can be if she is of type maybe yes or no instead of yes or no. So does anyone know the answer to this? Can she be 1 value? Can she be 2 values, 3 values, or infinity? TOS? Really? Because of feet? I didn't know feet were against TOS. But anyone know the answer to this? W. Gaffa has the answer C, and he is correct. We can just scout, right? We can just do just yes, just no, or nothing. So 3 possible values. Let's move on. Why would we use maybe even in the first place? Well, we can now write code like this. In this, we are extracting the value of Johnny, which is in maybe yes or no, to just yes or no here. And if Johnny is nothing, this entire code block will be short-circuited, so call will become nothing. And this helps us think, right? Because now we don't have to worry about that maybe value anymore. Same goes for Betty. And then we can just pattern match on it. So it makes our reasoning a little bit easier. Oh, another monad. Exactly. Maybe is also monad. You are right. Functor? We're not playing the functor game, unfortunately. I think functors are a little bit too advanced for our audience right now. Okay. How can we improve this code though? Because like what we're doing implicitly here is squashing the maybe. So we don't know if Betty didn't know anything or Johnny didn't know anything because Carl will just be nothing, right? So if we're running this code, we don't know which of these two functions crashed, and we like to fix that. So let's look in how do we can improve errors. And to do this, we are introducing this result data type, which is either an error A or an OK B. But to start, we first have to count again. How many possible values can Betty be if she is of result unit yes or no? Is she of 1 value, 2 values, 3 values, or infinity values? Does anyone know? Chat. See again. Exactly, we got see again. We can just count. You're right. It's not. Well, you could just count here. Error can only be unit, right? So we have to count yes or no. And you're right, Corruptical. Result is also a monad. Congratulations. Okay. However, in fact, we're gonna say it's stronger. Result of unit yes or no is isomorphic to maybe yes or no. So we can go from maybe yes or no to result yes or no. And we can go to maybe with result unit to yes or no. These things are sort of the same. They can change in themselves. Also, this error means change, right? This is a morphism error. So self-change, great. Right, so let's count even a bit further. What if we introduce another data type for just errors? So we have an error data type with Johnny nothing and Betty nothing. So let's count. How many possible answers can Betty be now if she is of result, errors, yes or no? Is she of 2, 3, 4, or affinity? Does anyone know the answer? Just do like the pattern matching in your head, I guess. difficult question. Maybe I'm gonna get another drink. You guys can think about it. Like C, I suppose. You're right. Gafa, our most participating member of the audience, has it correct again. Oh, Skybro, Ben. Anyway, yeah, you're correct, Gafa. Excellent. So how are we going to use this advanced error system, right? And this is like one of the most important points I want to drive home here, is that we can tag our functions with where they went wrong. This is actually something we're using right now in RISC production code. So we can say that the error occurred at Johnny, or we can say the error occurred at Betty here. And now if we squash, we know which part of the code went wrong. So I think this is like a really important thing to drive home, in that we can change these maybes into results and then tag it with an error. Okay, let's move on. Now, we want to introduce logging, and this is where all the trouble starts, I guess. Because sometimes we have these values that are a bit dubious. For example, we know that Johnny loves to go to parties, right? And if Johnny says no, when he knows the answer, there may be something strange with Johnny. So we want to warn in this case. We want to warn our other, like, the DevOps people saying, hey, Johnny ain't going. Something may be up. This is actually not valid Haskell at the moment, because we're in result. We can't do this kind of logging. So this is where we have to introduce transformers. Enter the transformers. To do this, we are attaching a logger transformer to call. So this is just logging T, and we wrap it around result. Does anyone see the monad here? Does anyone see the monad? Because it's changed now. It's bigger. Does anyone see it? I don't know. Well, let's move on. Yeah, so now we can actually tell the code which monad to use. So our original code is now one level deeper, so we need to lift it up. We need to go over the logger, and that's just what lift does, right? Hey, this maybe stuff, it should be inside result. And then our warning can be here. So everything is fine. There's 2. Yeah, exactly. So this is a monad, and this is another one. I guess technically, well, never mind. Yeah, so this is like the full code of that. And you can see it's become a little bit messy because we need to lift everything, right? We need to go over logging t and put it into result. And this is just, yeah, it's not clean at all. So maybe just James, you can't do any IO here. This monad has no access to IO at all. So we can't open a file here because we can only do things in result, or we can only do things in logging t. Mirror what you can do, everything with IO, but only logging with logging. Ah, yeah. Actually, you got it right. So you hit the hammer on the nail. They are restrictions. That's the entire point of Haskell. We restrict ourselves. So logging t only allows logging. Result only allows errors, and this is the happy path. You got it right. It's about restrictions, not about capabilities. So the other thing we need to do is we need to tell our code how are we going to use this logging, right? Now we have choice, right? Call function has some logging information inside it, and we need to tell it how to use it. So in this case, we're outputting it to std out. And in case of error, we're throwing it, and in this case, the application will crash. My question to chat is, why would you ever do this? Like, what's the point of using the restriction at all? Why would you not just use IO, right? Does anyone know this? Skybro knows. But what benefits do you see from doing this? It's a difficult question, though. You can predict what will happen. That's true, but it's not quite the answer I'm looking for. No files will be written. Yeah, this code can't write to files. That's correct. Okay, so I'm gonna tell it now. So we can choose what to do with logging in this case. So we don't know what logging will happen here. However, at the call side, we can decide if we want to run this to std out, or maybe we want to write this into a database, or maybe we want to write this into a file. We haven't chosen yet. Maybe even we want to run this into a test and see if the right logging messages appear. We can do all these things without knowing that's in the business logic. So we're separating that like very strongly from each other. Same with errors, right? They can be values, and we don't have to crash, but we can crash. So we are left with choice. What can we do is decide that later rather than immediately. Okay, so here we're gonna move on to the next level. What is the library aspect of MTL? And again, I want to remind everyone, there's the law of 2 feet, and at this point it will become like quite difficult to keep up what's going on. So if you feel that this is too difficult, just leave. You know, it's fine. I'll be happy to give this presentation anyway. So yeah, but there will be dragons here, okay? Yeah. So, but first, let's sketch the problem. Why don't we like transformers directly like this? Because they solve our problem kind of neatly. Well, calling lift everywhere, it's not very dry, right? We're repeating that lift. And we actually don't care about calling lift. We just want to be able to log, and we want to be able to do errors, right? We don't really care about selecting which particular monad we're in. We just want to have both, really. So, and the other problem is that any stack above 3 quickly becomes bloated with lifts. Like this lift problem we saw with just 1 there will become 2, will become 3. It becomes like unmanageable quickly. And there is also lift width, and you can Google lift width, but I'm not going to speak about lift width. It's an abomination, and you don't want to deal with that. Okay, it's like really complicated. Okay, so we're going to focus more about running computations with types now. We still use them as a thinking aid, and we still use them to detect bugs early. But this part of the presentation will be about running computations. Okay, so again, we're going to ask the question, what can Betty be if C is constrained by num A? Can C be 1 value? Can C be 2 value? Can C be 3 values? Infinity or unknown? Does anyone know this answer? I guess this is also a bit more difficult. Hello? Well, really difficult. Actually, so I'm just going to continue here. Initially, I thought infinity as well, but then I realized that you can also make an instance of yes or no. for num. And if you do that, there will be only 3 possible values, right? But and for example, if you have word 32, there will be 2 to the power 32 values. So at this point in the program, we don't actually know what values a is, because we only get a restriction of num. And we don't even know what instances there are of num, or if this will be used at all, you know? So at this point, it's unknown, I think. I went from infinity to unknown. But if it's an integer, it's infinity. But if it's an int, it's not infinity. It's 2 to the power 32, I believe. So yeah, it's unknown at this point. But large, yeah, you mean 2 to the power 32. But we have big ints in Haskell for integer, but it's not a big int for int. Like together, it's 2 to the 32. Yeah. So what is this num thing? You know, and actually this is what they call type class. And what you would do is you would just kind of attach the instance to a data. So we have integer and we have float. And what it does is they provide an implementation for that, and then you can use it like it's a num. So you can use plus and minus and etc. So we provide the implementation here, and then we can talk about num as a constraint in a function. That's the entire idea. And we can have our own numbers too. Of course, we can make our yes or no type a instance of num. And now yes or no is a number because we told it to be like this. This is the correct use of type class, of course. But there is something wrong with this instance. Does anyone know what's wrong with this instance of yes or no for num? Classes, instances, sure, like sounds like OOP. Well, maybe this is just how they trick us into OOP, you know? They just add like very clever branding about purity and whatnot. Who knows? It does sound like OOP, doesn't it? Does anyone know what's wrong with this? Skybro, you particular, you must know. This, I mean, actually, the particular implementation. I'm not talking about the instance itself, but that's okay. Where have I seen this? You don't even remember, do you? Oh, that's amazing. You're quite right, Wagava. It doesn't behave like number because the laws are broken. We are breaking commutativity of plus. So if you look at the definition of this, x plus y is equal to y plus x. But what we're doing here is we're dropping y. So x plus y will we'll drop y, you know, on the right side. So this will be dropped and this will be dropped, meaning that x will become equal to y, which is not true. So we're breaking commutativity law. But laws are a presentation for another day, so we'll skip this. Anyway, I'm getting a bit distracted, I think. How about this? How many possible answers can this be? Is it 1, 2, 3, infinity, or unknown? And we're just saying that Betty is inside a monad. We don't know which monad, but it is inside a monad. At least something that implements the monad instance. It may even break the law of monad, but it has the instance, the infinity. No, the answer, unfortunately, is also unknown, because this monad can be a subtype that's in infinite length. So this M can also be infinite, but it can also be maybe. Isn't infinity unknown? That's that. Have you been listening to the Philosophize This podcast? Because you may be quite correct. I think they have an episode about infinity. Anyway, okay. So let's go on with the questions, right? What is the value of D? Is it yes, no, compel error, or runtime error? We're saying Betty is pure yes, and then we're padding matching on Betty, like it's a maybe, X, or to X, or nothing to no. What is this? What does this code do? Does anyone know? It's I guess it's also a pretty difficult question. This is the dragon part, you know. You are correct, Gaffa. It's A, because the compiler will just figure out this is a maybe. We can be maybe, right? We can be any monad, and since maybe is a monad, it's just fine. Yes, you're both right. Congratulations. Good job. Okay, let's move on. Same question, except for Y. Betty is again pure yes. We're gonna pattern match on it, but now we're gonna use right and left. What is the value of y? And I guess this answer will be quite easy since you both got the other one correct. Yes, A, exactly. It is yes. So we figured out that Betty in this case is an either. And before it was maybe. So the compiler can figure out the monad stack, or at least this one monad value. All of this stuff is valid. It's all compiles. It's all proper Haskell. It's all usable. It's amazing. So let's just describe what we want from our call function. We want to have a monad with some errors, and we want to have a logger around our monad. And then we want to return yes or no. Let's put them to work, and let's forget about lift. So there is a couple of differences here. We don't use the result anymore directly, right? We are now using throw error instead. And that's because we have to comply with the monad error interface. Remember plus and minus in num? That's the exact same thing here. And we can now log with monad logger. This thing is implemented in monad logger. So this is all inside the same base monad. And now you may wonder, like, how do we even use this stuff, right? Well, we just use it at the call side. We tell it which order to unpack call. So in this case, we're gonna first run the std logging t, and we're gonna then run accept t out. But we can flip these as well. That's fine. The order doesn't matter anymore because the instances will do it for us. And then we're gonna pattern match, and then we're gonna print. So everything works out perfectly. What are the advantages of doing it this way? We no longer need to call lift, so we don't get 5 different lifts in our code anymore. So it's all like pretty clean. Stack order is determined by call side, which is pretty cool. So we don't have to worry about it anymore. I guess that's an advantage. It's also potentially better testable in that we can, see what the log messages were. But this is shared with transformers, right? If you would just use transformers without MTL, like without the type classes, you still get this testability advantage. And the call side still determines what to do with effects. There are 2 big disadvantages. For MTL directly, only MTL, the type errors get like really bad. If you, for example, miss an argument, it will start complaining about that your monad has to be a reader. And that's so annoying. But you need to I guess you need to recognize that or something. I don't know. It won't point out exactly where this error is either. So that's like really difficult. And then there's also the n-squared instances problem. And I'm not going to talk about that. Okay. Because we can't solve this in MTL. We have to look at alternatives. And that's what you would do. But I honestly don't know which one is best. So I'm just like listing these out here and say to you all, to your own research. I know for a fact one of my viewers really likes polysemi. So I would, urge everyone to check that one out. It sounds really cool. Fused effects is also fast apparently, by accident, but it's still fast. By the way, do is considered harmful. Just write a reader instance for every monad. Problem solved. Yeah, I did it once. I don't know which is best. Yeah, so does anyone have any questions about this stuff? Did I make everything clear? Is anyone confused by anything? Please speak up now. I'm gonna say, assume the silence is a no, but you can just, that was enlightening. Really? Thanks for watching. Leave a like and subscribe. All right, the bonus slides. There are bonus slides, everyone. Bonus slides, bonus slides, bonus slides, bonus slides. Apply correctly. These are like sketches, basically. We make an A, that's the number, any number, also yes or no. And then we make a monad reader out of it. This is our function, right? It's just a monad. And now we can apply 2 to it. This is correct Haskell, by the way. So the functions named first names. I don't know. I needed to have names that are relatable, I guess. And we can go a step further, right? We can make any number A, and we can make it a reader N. We can make a reader M, and then wrap N around M. This is also valid Haskell. So, point here is that arrow instance is reader. I don't know. You also got this thing, right? We can apply no to this thing, and it's still valid monad. I don't know. Also compiles. I don't know. I guess this is just const. Who knows? We also fake row-time polymorphism. And we can use lenses for state. So yeah. People. This is like the bonus slide, I guess. If you haven't had enough at this point, I don't know what else to do. I threw all my magic against you. You're too strong for my magic. But that's it. That's the presentation. I don't know. Well, maybe just James found the presentation enlightening. I hope other people would find it enlightening. I don't know. Where or whom are you presenting this? I'm presenting it at my company, Riskbook. So we're like a Haskell shop making some trading platform, I guess. For it's not really a trading platform. It's like building a financial contract platform for massive corporations that try to pawn off risk. Yeah. So yeah, and they like programming in Haskell, so they like this stuff. This is actually like my learnings from Reflex mostly. This is like what you learn from Reflex. You can deal with MTL. I'm not gonna propose this as a use. I'm just gonna tell them this exists, and I like the important part is that we know the advantages, but we definitely know the disadvantages. Like I wanna really drive these home actually, and I also wanna point out alternatives. That's like what I kind of want to get. But currently we're not really doing any MTL stuff, I guess. Well, I sneaked in a little bit, not much. I did lens stuff, I guess. Protocol still around. I think ironically enough, one of the things I wanna point out mostly is this one, because this is simple. So I have some faith in that people will hopefully copy this idea of just using either to tag errors. It's so easy idea. Turns out it's a lot of work. I guess it would be really difficult to teach scientists because, maybe some of them would have some ego and that would be more difficult to teach. I don't know. You don't have the requisite background. You have the background to teach, right? I'm pretty confident your Python is much better than my Python. If I try to teach someone loops. Oh, you just don't, and you tell them about recursion instead, because that's probably more natural, considering they should already know about inductive proofs, or it's inductive, right? Scientists don't have any necessary background for learning. You haven't taught anyone loops, I can see. I have not taught anyone loops, definitely not. I don't. Well, no. I taught some Chinese students about C++. I mostly told them about how to de-shitify their code, because they make such a fucking mess of everything. Just they call variables x, y, z, and then they go on, x1, x2, x3, x4, and I'm like, god damn it, I can't make any heads or tails of this code. It's crazy. Just follow the types. I find they want to know the application immediately. You set inductive proof. Well, are these scientists or are these like students? It's inductive, right? Deduct. Yeah, it is this one. I think I got it right. Because this is recursion, isn't it? Oh, it's not. This is infinite series. Damn it. Okay, this is my stream, I guess, for today. I haven't done a proof once doing science. Are you sure? You're a scientist? What science do you do then? Doesn't sound right. What did you do? I'm a chemist. Oh, you deal with the real world. Ugh, the real world. Yeah, actually, you have to figure out nature. It sounds awful. Nature. It's kind of asking why do we have gravity? We just do, okay? Why do we have molecules? Practical, tell me what is an atom? Magic. I feel like I wanna emphasize this particular slide, and I wanna emphasize the advantages and disadvantages. Because people ask me this, why are you doing this? I told it in the motivation, right? Why I did it. Maybe my motivation is shitty, or maybe people just drop by halfway and don't encounter the motivation. Oh well. I think enough practice. Spent enough time on this. I'm considering recording this session, and then I'll try to cut the crap and have another video on the main channel, actually. Because prepared presentations do well. I can edit it as well. Make sure I don't speak like an idiot. Yeah, that's a good idea. Anyway, this is my stream. Thanks for watching, everyone. Oh, I can rate someone, I guess. Is anyone online? Yeah, I'm still here. Patat. It means French fries. Oh. French fries, by the way. This guy actually is a big time Hascaller as well. How does it work? Presentation atop the NC terminal is a small tool that allows you to presentation using only NC terminal. It does not require any curses. Are you saying I can? Oh, I'm gonna try this tomorrow. But does it have code highlighting as well? That's really important for me. I have arc mode, and arc mode is in Pandoc, and Pandoc can patat. Oh my god, we're gonna do this. Oh, we're gonna do this right now, actually. Okay, you convinced me, Skybro. How do I use it with Pandoc? This is so cool. But how do we use it? I need to convert it to what? Running patat options file. You won't be able to... Well, we can. I guess we can try installing it from X packages. Just install patat. Which means French fries, by the way. I want to drive that home. That's what I'm seeing if I'm reading that word. Because I'm Dutch. This guy is also Dutch. That's how I know. Yes. I mean, he has a Dutch name, Jasper. It's actually like a bastardization of my name, goddammit. Oh, we don't know about patat. I'm not sure if this is gonna be... I don't know. I'm tired, Skybro. It doesn't have it. It doesn't have it in Nix. He didn't bother to upload it to Hackage. I guess. Something. Did I misspell it? No, it's patat. No, it's only from Hackage, to be honest. That's what you get. You get it automatically. Oh, it's Haskell packages.patat, of course. There you go. It's broken. Fuck me. Okay. Package is unstable. I probably should mark this not broken if it's building. No, we don't need flakes. We have a separate pin for this. Like that flakes feature is a bit how to say, behind the curve. I'm way ahead of you, boy. I'm way ahead of you. They're basically providing UX for stuff you can already do. Even copy it for cache. Oh. But still, we don't know how to get that file format. Patching sources. Oh. Okay. Haskell packages. We need to do jailbreak. Yeah. I forgot how to do this. I don't want to do this now. I'm sorry. We'll do this another time. It's a really good idea. We'll I'll probably do this tomorrow morning before the presentation because I want to flex, but I don't want to figure it out right now because I'm too tired. But I know how to figure this out because I just need to jailbreak it. But to do that, I need to. I'll probably need to make a shell with patat or something. Patat. Yeah, something like that, you know. But I'm just too tired now. I want to chill for a bit. Thanks for watching. Everyone left. But this is a great idea. Let's actually put it to the promo. This is a really good idea. See you later, man. Thanks for watching. Bye. Thanks for having some feedback on my presentation as well. That's good. Bye.